Good day, everyone. My name is Marvin Alphonse. I am here to show you guys how to determine common, run, and start on the domestic compressor, refrigerator compressor, single phase. I have my multimeter and also I have something to take note. So with my readings, I will be able to determine which terminal is run, which terminal is start, and which terminal is common. Right, so my meter is set on continuity. It's on OL. Right? So first to begin, always check your compressor to the earth. Take piece of the terminal to touch copper or anywhere that is grounded totally, and from there you check each terminal. Nothing. So this compressor is not grounded. So now we are going to check between the terminals. So I'm looking at the right terminal and the top terminal. I'm getting 1.9. 1.9. So I'm going to check the top terminal and the far left cup terminal. I'm getting 6.6. 6.6. Now I'm going to check the two bottom terminals. I'm getting 8.5. So this is what I'm getting with the compressor. 8.5 between the two bottom terminals, 1.9 between the two terminals, the top and the right. Top and left terminal, I'm getting 6.6. So this is the longest run where it has to pass through all the terminals. That is why you're getting the highest resistance. So it's safe to say this start winding. This is run. From start to the top, which is common, getting 6.6. So the top is common, and common to across here is run. Shortest resistance. So I'm going to identify it here. So it will be easy for any technician who comes across. They have to do the job after. They won't have to check the meter, use the meter and check the compressor. Also, I have a device that I made with a doorbell switch to act as a relay. I have my common, my run, and my start. So let's see if this compressor is good, if it's running. First to begin, I disconnect my leads from my meter and change it to amperage. AC amps. I take my common and put it on the top terminal. Then I take my run and the other terminal, the other clip on the run terminal. Start, sorry. Okay. Let's see what's gonna happen here. Take my meter, put it over the common. All right. Here goes. Plug in. Fantastic. Now you guys might be able to hear it. The compressor is running. Compressor is running. The only thing now is to see if it's pumping. You normally take your fingers Right. And check the suction and the discharge line. Right. That's one compressor we have completed. So we have the other two compressors to check. Right. Now we're going to attach our leads and switch to continuity. Right. Back on OL. We're going to check the bottom right terminal and the top terminal. I'm getting 10.2. That's a bit high. We're going to check the top terminal and the far left terminal. Getting 16.3. Now, we're going to check the last two terminals, the bottom terminals. Getting a large amperage, sorry, a large resistance, 26. That is rather high. Now I'm going to check to see if it's burnt. Brass, left terminal, right terminal, top terminal. Well, I touched the body just to make sure it was getting proper connection. Compressor is reading good. Now, let's give it the other test to see if it's starting. My alligator clips. Come on. Run. Then start. Okay. You put the meter on continuity. Disconnect my leads. Okay. I'm going to plug in and press the switch to act as relay to see if it's going to start. Right? I'm plugging in and I press the doorbell. Compressor isn't running. I'm going to try one more time. Nope. This compressor isn't good. It's electrically good, but not mechanically good. Now we have one more compressor to check. Disconnect. Take my leads. Put it in. Switch to continuity. Right. It's functioning. Going to check the right terminal and the top terminal. I'm getting 11.3. Strain. The top terminal and the far left terminal. I'm getting 14.2. Now, I'm going to check the two bottom terminals. getting 25.3. That's strange. A very small compressor with that amperage. Let's check to see if it's going to earth. Whenever you come across a compressor like this, you can use the silver part on the back as the ground, and there's a ground terminal here instead of using the copper. Because sometimes you don't get good connection, you have to scrape the copper when you are checking for earth. So you can simply use the ground and each terminal, no resistance, nothing. So this compressor isn't burnt also. Well, once again, I'm going to pull out my device with my doorbell switch, what acts as a relay. My alligator clips, common, run, and start. Having a little problem here. It's so small, it's a bit tricky. So it's just like the other compressor. 25.3. This is the highest resistance. Okay, sorry about that. With the highest resistance, that is start and run. Smallest resistance is between common and run. That's 11.3. Well, let's give it a try and see if the compressor starts. Okay. My trusty relay. When a compressor starts. When it energizes, right? Go to amperage, AC amperage, common, and plug it in. Let me just flip my meter so I could see the values. Plugged in, nothing. Try one more time, nothing. This compressor is not good. Check for vibration. Yes, the compressor is humming. So that means it's locked. Normally you take a screwdriver to feel it. Take something that's insulated, because sometimes a compressor could be faulty and it didn't show up on your meter, and you could get a little sting, nothing much. So always remember to be cautious, remember your PPE, to be grounded, to use all your safety equipment. Okay, so out of the three compressors, one is good, but we identified all common, run, and start on all the compressors. Right? So just remember what I said. Once you check within the highest values of the terminals is always the run and the start. Right? So that's it. Good evening, everyone. Goodbye.